How big is space? Have you ever looked up at the night sky and wondered how big it really is? The stars may look tiny, but they are actually enormous balls of fire many times the size of Earth. They are also trillions of kilometers away, and between them there is space, lots and lots of space. Think about how quickly a light turns on when you flick a switch, traveling at that speed. It takes light from the sun nearly 8.5 minutes just to reach Earth and years to reach the next nearest stars. It's incredible to think about how long it would take to get to the edge of the universe. But does space even end, like the end of a map? Or does it go on forever? How do we go about measuring it? What if it's getting bigger or smaller? When you try to picture the size of the universe, if your brain doesn't feel a bit wobbly, then you probably haven't imagined it properly. Let's see, try to wrap our heads around just how incredibly, mind bogglingly, spectacularly huge space really is. Most of the time, we can easily see how big or small something is. Your piece of cake is larger than mine. A mouse is smaller than an elephant. The sea is not the same size as a bee. We can compare these things just by looking at them. But the question of how big space is pushes us beyond our everyday experiences. On Earth, everything has edges and limits. Your bedroom has walls, your school has a fence around it. Even the biggest things we know, ocean and continents, begin and end somewhere. Space is so enormous that our usual ways of measuring and comparing just don't work. You can't walk to the edge to see how far it goes. You can't pull a ruler across it. You can't even see most of it, no matter how hard you squint. And that's not the only problem. We don't even know if space can be measured. It might go on forever and ever. It might even curve back on itself, like in a video game where you zoom off the right of the screen and instantly reappear on the left. This concept was so strange that even brilliant scientists struggled to understand them. Trying to figure out how big the universe is can also tell us how it works, where we came from, and what things humans could explore in the future. Maybe space is like a giant snow globe with galaxies, stars, and planets floating around inside. If you travel far enough, you might bump into an edge you can't touch. Perhaps the snow globe is just one of many sitting on the shelf in an alien gift shop. Flexing our brains with weird and wonderful theories helps us imagine the vastness of space. These ideas don't have to be exactly right, but thinking about them can help us learning new things. Space might be quite small, but full of mirrors that make it look endless. When we look through a telescope, perhaps we are seeing the same star reflecting back and forth infinitely, as if we are standing between two mirrors. Or maybe we are all part of a complicated computer game. As we look out and explore new parts of the playing area, cosmic programmers create more levels in the game. Scientists have developed some clever techniques to measure space. One is using light as a helpful measuring stick. Light travels nearly 9.5 trillion kilometers in an Earth's year. We call this measure of distance a light year. It sounds like an amount of time, but it's actually a unit of distance. It's very large, which makes enormous universal distance easier to write down. Light years also remind us that when we see stars, we are looking at how they appeared when their light first began its journey to Earth. In other words, looking at the night sky as it's looking back in time. Astronomers also measure distances in space by using the brightness of stars. Some types of stars are always explored with the same brightness. Since we know the rate at which light fades as it travels, we can figure out how far away those stars or be how bright or dim they look from Earth. Another technique involves studying the movements of galaxies. Their light squashes and turns blue if they are moving towards us. It stretches and turns red. If they are moving away from us, we have found that nearly all of them are moving away from us and that the universe is expanding. We can also learn more about the universe age, size, and formation of looking for patterns in radiation left by the Big Bang. This is called the cosmic microwave background radiation. By combining everything they observe with computer models of the universe, astronomers can make predictions about what's happening in regions too distant to see directly. Using these techniques, astronomers have discovered that space is very big. The part we can see stretches about 46.5 billion light years in every direction from Earth. But there's only the observable universe beyond that. There may be much more we can't see. The light from objects beyond this limit wouldn't have had enough time since the Big Bang to reach us yet. The universe could be much bigger than we can see, or it might even be infinite, going on forever in all directions. Now sit yourself down because here comes something truly strange. Space itself is expanding. This doesn't just mean that everything is moving apart, it means the very fabric of space is getting larger. Imagine you are a dot living on the surface of a giant balloon as it inflates. Even if you don't move, the balloon surface would carry you further away from the every other dot. So while light has been traveling to us from distant galaxies, space has also been stretching. This means these galaxies are now even further away than they were when their light started its journey. It also explains how the universe can be just 13.8 billion years old, yet over 93 billion light years in diameter. So, how big is space? While we know it's big, we can't be sure how big it is. What we do know is that the part we can detect is almost impossibly huge. It's about 93 billion light years across and contains at least 2 trillion galaxies. But the true size of space is almost certainly much greater than this, and it may even be infinite. This question is fascinating on itself, but learning about the scale of space also brings practical benefits. It drives us to invent new technology, inspires new mathematical techniques, and pushes us to think about our place in the universe. The methods scientists use to measure space have even led to inventions that help us in everyday life, from GPS system to medical imaging. The next time you look up at the sky, remember that you are peering deep into both space and history. But if you are hoping to go and visit the outer reaches of the universe someday, you will probably be disappointed. Our fastest rocket would take over 6,000 years to reach the nearest star after the sun. The edge of the observable universe is 10 billion times farther than that, and getting farther all the time. Thank you for watching.